Hey guys, very good evening to all of you, and welcome to my session once again. I am Pushkar Ranjan, bearing visa number 1BE20CS119, currently studying in 6th semester in the Department of Computer Science and Engineering at SVC Bangalore. The subject for which I am carrying out this session today is for cloud computing, with the subject code as 18CS643, and the topic for which we are going to see is the machine reference model. So let's begin. When an execution environment is virtualized and unlike levels of stack of computation, then it requires a reference model which defines the interfaces within the level of abstraction, and this level of abstraction hides the details of implementations. So up to this line we are knowing that for any model, for any implementation we require a model. That model will help us to know about the abstraction, how we are going to implement that. This project an idea that virtualization techniques can substitute any one layer and can intercept the calls which are directed to it. That's why a clear separation within the layers can simplify their implementations, which only need an emulation of the interfaces and a proper response with the underlying layer. At the base layer, the model for the hardware is declared or manifested in terms of architecture, that is instruction set architecture ISA. So this is the how the machine reference model will looks like. As you can see, the uppermost layer is the applications layer. Next will be the libraries layer. Third will be the operating system. And the fourth layer will be the hardware, which is the base layer. From the applications to the libraries, we are making the API calls. From the library to operating system, we are making the system calls. And from the application libraries and operating system, they are making the ISA calls for the hardware. Instruction set architecture, ISA. ISA defines the instruction set for the processor, registers, memory, and interrupt management. It is an interface between software and hardware, and it is mandatory for an operating system developer of applications who directly manage core hardware. The operating system layer is separated by the application binary interface from the application and libraries, which are managed by the operating system. The next, we are having application binary interface, ABI. The ABI covers the facts such as the low-level data types and call conventions. At it also defines a format for many programs. Mainly, the system calls are defined at this level. Moreover, this is the type of interface enables that the portability of the various applications and the libraries across operating system which employ the same API. The application programming interface is represented by the highest level of the abstraction. This API interfaces application to libraries and or the core operating system. Action is to be performed in the application level API, ABI, and the two which are responsible to make it done. Mainly the CPU runs the two privilege levels. Number first is user mode and the second is kernel mode. User mode. In this mode, memory access is restricted up to some limit, whereas access to peripherals is denied. In kernel mode, in this mode, the CPU has instructions that manage the memory and how to be accessed, and it also has instructions that enable access to the peripherals like the disks and the network cards. For one running program to another running program, the CPU switches automatically. The expansions and the packages of computing gadgets are simplified through the layered approach. The applications of multitasking and co-lifestyles of more than one executing is simplified through this layered approach. So this is the diagram for the ring structure, in which the ring 3 is the least privileged, which can be used as a user mode. The ring 0, 1, 2. This all three rings can be together called as privileged mode. And under the layer, that is the first ring 0, it will be the most privileged supervisor mode. ISA. ISA has been divided into two security classes, privileged instructions and non-privileged instructions. Non-privileged instructions that can be used without interfering with other tasks because of do not access shared resources. Example, arithmetic, floating, and fixed point. Privileged instructions, they are executed under the specific restrictions and are mostly used for the sensitive operations, which expose or modify the privileged state. Behavior sensitive, operate on input and output. Control sensitive, alter the state of CPU register. Security ring. Ring 0 is in the most privileged level and used by the kernel. Ring 1 and 2 are used by the operating system level services, and R3 is the least privileged level, is used by the user. The recent system supports two levels, ring 0 equal to supervisor mode and the ring 3 equal to user mode. So this is all about my session today. I hope you got it. Thank you and take care. Bye.